Setting up body deformation poses requires a little bit of scripting, but it's very easy and you can just take an existing script and modify that. In this example, let's create a pose for the elbow when it's bent. Let's go to Base Human and open the Python file and copy the connect target's body function. Now I go back to my character and I paste the function. Now you can see the function here. Let's comment out everything except the first part and the last part, and make the secondary models an empty list. At this point, the script wouldn't do anything, and we can just one by one comment things back. So now for the elbow bend, uncomment this line, and let's understand this function call first. First argument is the mesh. So let's call this cloth main geo. Second one is the pose mesh name. When we sculpt the shape later, we'll have to make sure it's called elbow bend. The D poses is the actual pose, meaning the arm elbow FK control rotating from -35 to -90. The reason why there is a driver get ADOS flag is because the command won't connect directly to the arm elbow FK control, since that wouldn't work in IK. So for that, it looks at the values of the driver get ADOS attribute when the pose is activated, and connects to that. In the driven key curve type attribute, we specify that it should ease in. Now let's create the pose mesh. And sculpt it. For mirroring, I choose the Mirror No Base tool. And then I export it in the target section. You can see this is the file he just created. It's the same name as the mesh. This will then be imported in the import targets function. And now I'll build again. I'm just going to run everything up until connect target body function, so I can hold the scene and then run connect target body function separately. Now you can see how the pose comes in as you rotate the elbow, and the same goes for the right side. He mirrored that correctly. Let's look at another pose. Let's fix the volume loss on the wrist as it rotates up. Now this is slightly more complex, because since the wrist can rotate into all directions, you cannot just connect it to a simple driver attribute. First, let's uncomment this line and change the mesh name. For the poses, you have this wrist left up, which is the name of the pose interpolator, which is created in those lines. So let's uncomment those lines also. So here's the name again. Then this is the joint that the interpolator will use to calculate the pose. And this is the control that we are using to define those poses. The values are rotation. So up would be rotation Z minus 80. Now let's sculpt the pose. And everything else is the same as what we did before. Let's rebuild. And now we can see it's working too. Now let's try to understand the rest of the script by looking at base human. For the leg, I'm creating a pose interpolator also. Then you could just assign it the same way as we did with the wrist. But you may have noticed already that generally in pose interpolators, as you go to a pose it turns on, but if you go further than that, the pose will fade out again. This is why for the leg up, here I added a combination of driven keys and using the output of that as a driver get ADUS input. Let's look at the result of that. You can see that the blend shape turns on correctly as it comes closer and closer to the pose, and now that it's at 1, it stays there as it goes further. By default, the pose would fade out again after it goes further, which often results in a very unstable looking motion. Now let's look at secondary models. Secondary models are some extra meshes that are moving along the main geo. In this case, it's the glove on the right side and those cubes on the shoulder. They are sharing a similar skin cluster than the skin. If you specify them as secondary model, the connect target functions will assign blend shapes to them parallel to the main blend shape. But it will only create those secondary blend shape if those pose meshes for these secondary models actually exist, and they need to be in the correct naming convention. So in this example, it's those meshes here. They start with the model name, 2 underscores, and then the pose name. And don't worry, you don't have to create those manually. There's a tool for it. It's Geometry Warp Secondary Poses. Let's just recreate the ones for the cubes. First I set the main model, then the secondary model, and then I select all the poses that I want to warp. And then I click Warp. Okay, now you can see he stretched that mesh. If you want to keep it rigid, just activate the Rigid Islands flag and rewarp again. And all good. If the model changes, you can warp the pose meshes to the new model. In this model change, the head is bigger, right foot is bigger, and the right fingers are longer. And those are the shapes we want to warp. So we go to Geometry Warp Poses. Then set the old mesh in the From field and the new mesh in the To field. Then select the pose meshes and click Warp. And it's all warped. He keeps the old poses by giving them a 2 underscore prefix, but you can delete those. Let's talk about the warp mode. If the topology of the new mesh is the same, you can use any of the 3 options, but try matrix first, since that works best in most cases. If the topology of the new mesh is different, in that case only wrap deformer will work.